Hello and welcome to this math tutorial class presented to you by O3SCHOOLS JAMB app. And in this class, we shall be taking a look at the topic, which is probability. Probability. Now, before I try to go deep to it, let's talk about why you should get your O3SCHOOLS JAMB app. Well, O3SCHOOLS JAMB app has so many features which aid learning and aids quick assimilation as a student preparing for JAMB. Some of these features are the mock exam feature, in which you can actually practice writing your JAMB well as many times as you want until that day. You can actually test yourself, see the time, see how long you spend per question, see how long you spend per subject, and see how long it takes you total, so that you can actually start reducing your time and making yourself more efficient than you were when you started. In addition to these things, you also have one which is my personal favorite, the question search feature, which lets you search for a particular keyword or topic name, and it brings out everything Jamba sets as regards to that keyword you searched for. For example, if you simply go to the question search, choose mathematics and search for probability, a bunch of questions in probability comes out, and you can just begin to solve. So you see, when you read and you finish a particular topic, to test yourself, you can come to the app and you can use the question search feature to try and find questions in probability. Even if you don't want to do that, you could also go to the mock exam, and within this mock exam mode, you can actually select probability as a topic you want to answer. What the app does is that it then picks out all the questions probability and gives to you, and removes any other subject. So you can try to test yourself not just per topic now, per subject rather, but also per topic. So O3SCHOOLS app is very versatile and useful. And well, to gain access to all these use, you don't just have to install the app, no. You also have to activate it. Activation is very important, and activation costs 2,500 naira only. A very small amount. Some of us spend it on lunch in one day. So you should know that's very, very small. It is cheaper than you buying your past questions, but it has way more to offer you. So 2,500 naira only. And there are different ways to activate this app. There's paying it through Google Play. There's paying online with your debit card, which is Paystack. And you could also use transfer. Whichever method you use, simply follow the instructions on the app and your app will be activated. It is really that easy. So get your O3SCHOOLS JAMB app, activate it, and let's go on this journey of success. So for now, we are looking at probability. Probability studies chances. Is something going to happen? Is it not going to happen? And in probability, there are two ways to study it. There is classical probability, and then there is statistical probability. What's the difference? Well, in classical probability, we don't take into account what has happened to influence what might happen. What do I mean? If you take a coin has heads and tails. When you throw this coin up, it can either give you heads or tails. In classical probability, we expect an equal chance. But in reality, at times, if you throw a coin, you may end up getting way more heads than tails. And with that, you have common sense logic dictating that if you are going to gamble on that, you should expect it to come out heads more. You see, it's kind of like, okay, a different example, a woman giving birth to children. If this woman has given birth to 6 children, for example, and they were all boys, if she was to give birth again, you have to expect that it is more likely for her to give birth to a boy than a girl. That is statistical probability, taking what has happened into account. But as far as classical probability is concerned, no matter what has happened before, that's not the issue. It's still the fact that a woman giving birth either gives birth to a boy or a girl. So from classical probability, they expect it to be equal chances, but statistical makes use of what has happened before to determine the likelihood of what may happen next. But whether statistical or classical, probability has a simple formula. That is, as probability equals to number of required outcomes, over number of possible outcomes. Now, that simply means if something wants to happen, say for example, I want to pick a boy out of a class of 5 boys and 10 girls. If I'm picking blindly, without actually using bias, then how many possible ways could I pick? Remember, I said there are 5 boys and 10 girls. If I want to pick a boy, how many possible ways could I pick a boy? Well, there are 5 boys, so I have 5 different ways that I could touch somebody and that person is a boy. So 5 boys. But how many possible outcomes were there? It could have been either of the 5 boys or either of the 10 girls. And 5 plus 10 is 15. And we like reducing to the lowest form, so that becomes 1 over 3. That means in this class, picking without bias, the probability of picking a boy is 1 in 3. That's how probability works. It is truly this simple. But there are a few things you need to know that help you in the probability. For one, probability with all means plus. The probability of picking this or that means probability of this plus the probability of that. But on the other hand, and means times. Probability of picking this and probability of picking that means probability of picking this times the probability of picking that. So please note, when answering the questions, just roll it through your head. Is it this or this or this and this? If it's this or this, is plus. This and this, it is what? Times. Very, very simple. Then please note, the maximum probability an object can have is 1. Maximum probability is 1. So if something is certain to happen, guaranteed to happen, for a guarantee, the probability is equal to 1. I'm going to give a very, very morbid example, but the probability that a human being will die is 1. Will not be today, hopefully, and will not be for a long time. You live a long, happy life, but eventually, all living things die. So the probability of death occurring in somebody's life is always 1. It's a guarantee. But for something that cannot possibly happen, probability, say for example, of you suddenly flying is 0. Probability of you suddenly turning into grass is 0. It's not possible. So for things like that that cannot happen, not possible, in that case, the probability is 0. So the closer the probability is to 1, the more likely it is to happen. The closer it is to 0, the more likely it is to not happen. Then please note, that therefore means that the probability of something happening plus the probability of that same thing not happening is always going to be equal to 1. So if you sum all the ways something can happen, and then you sum all the ways it cannot happen, all these probabilities always end up adding to 1, which means that if I collect like terms or make probability of happen solve the formula, it will be 1 minus probability of not happen. So this is the gist of probability. Likely to happen has a higher value than not likely to happen. If I sum all the ways any event can happen, it always adds up back to 1. So keep that simple formula for probability in mind. Remember that guaranteed things to happen is 1, since guaranteed not to happen is 0, and this times or is plus. Then one thing I remind us is there are some cases where we are picking objects in some questions, balls, and they tell you about with replacement or without replacement. Please note that is key, because if I was picking out of 8 with replacement, it means if I pick now, after picking it, I drop it back and I still have 8. If I was picking without replacement, after picking 1 from 8, I should be left with 7. So any probability should be calculated with the fact that there are only 7 things left. So in a question, just remember to check whether this is happening with replacement or without replacement. So those are the key ideas of what we need to know in probability. So without further ado, it is time for us to open our O3SCHOOLS JAMB app and actually begin to solve some questions. All right, let's see. The first one is from the year 2005. This is actually question number 49. And it says, a box contains 5 blue balls, blue is 5, 3 red balls, red is 3, and 2 white balls, white is 2. 2 balls are selected from the box with replacement. Remember the key, with replacement. That means anytime I remove one, I put it back in. Find the probability of obtaining 2 blue balls or 2 red balls. So if I'm picking 2 balls and replacing every time I pick, what's the probability that I either get 2 balls and they are both blue, or 2 balls and they are both red? So let's analyze. Well, probability we are looking for right now is probability of picking a blue ball. So pick 2 blue balls means and, right? 1 blue ball and another blue ball. And it said either this or probability of picking a red ball and another red ball. Now remember, we said and is times, or is plus. So what's the probability of picking a blue ball in this situation? How many blue balls do I have? I have 5 blue balls. How many balls are there in total? 5 plus 3, 8 plus 2, 10. And the probability of picking a blue ball is 5 over 10. And becomes times. Then because I replaced it, means after taking 1 blue ball, I put it back in. So I still have 5 blue balls and everything is still 10. So the probability remains 5 over 10. All becomes plus. And now probability of picking a red ball. There are 3 red balls. So 3 over possible outcomes is 10. So and this times, then 3 over 10 again. 5 times 5 is 25, 10 times 10 is 100. 3 times 3 is 9, 10 times 10 is 100. And then 25 plus 9 gives us 34 over 100. If you check your question, that is not part of the options. Just remember, they always like putting the probability in simplest form. So 2 here is 17, 2 here is 50, giving me 17 over 50, which is option A. So you see, very, very simple. The idea of probability is a very, very simple topic to grasp. Okay, let's see what's next. For our next question, this one comes from the year 1994. This was question 39. For this one, it was said that in a survey, it was observed that 20 students read newspapers and 35 read novels. 20 students read newspapers and 35 read novels. If 40 of the students read either newspapers or novels, what is the probability of the students who read both newspapers and novels? Now, before the answers about probability, based on the nature of this question, your mind should go to set, because I'm now having some people doing some things that kind of overlap. Let's try this. If I call this one for newspapers, and this is one for, okay, let's call newspaper new and novel, nov. And we are told 20 read newspapers, while 35 read novels. While there are 40 that read either. So there are 40 people that make up this group. Also get that people that are reading newspaper or novel must be 40 in total. Probability of students who read both. So that means there are some who read the two. So if X are reading the two, number of those reading just newspaper will become 20 minus X. And if 35 are reading novels and newspapers, while some are reading newspapers, then just novels becomes 35 minus the number that reads both, which is x. And once I get here, I know therefore that if I sum everything, 20 minus x plus 35 minus x, it should give me students that do both, which is 40. Minus x plus x is 0. 20 plus 35 is 55. Minus x equals 40. Take minus x to the right. 55 minus 40 equals x. And therefore x must be 15. That means 15 students actually read both. So they ask me to find probability of finding a student who reads both. How many read both? 15. How many students do we have total? 40. Well, remember, we have to reduce. 5 into 15 is 3. 5 into 40 is 8. Giving me 3 over 8, which is option C. So you see, no matter the question, the idea, the way of solving, the methodology, it remains the same for probability. It is number of possible outcomes, which in this case was number of possible people reading both over number of possible outcomes, which is number of people who are involved in the scenario at all. Okay, the next one, 1994, which is the same year as the previous question, but now we are going all the way to question 49. And this one has a table. And okay, let's just draw the table for fun. On the table, there is age, and then there is number. When the age is 10, the number is 6. 11, the number is 27. 12, the number is 7. What's the probability that a pupil chosen at random is at least 11 years old? Remember, at least means the smallest is 11, or can go above. If they tell you at most 11, that then means that the highest is 11, but you can go below. So following that logic, at least 11 means from this place forward. That means probability of picking somebody being at least 11 is, how many are 11? 27. Then 12 is 7. All over, everybody together, 6 plus 27 plus 7. 27 plus 7 is 34. And the summation here is 40. Now remember, we also reduce. So 2 into 34 is 17. 2 into 40 is 20. Which, as you can see, is option B. So probability is one of the easiest topics. I know I said a lot about different topics, but some of them are truly that easy. It's simply the number of required outcomes over number of possible outcomes. Let's check out another one, this time from 1995, question 50. Okay, I think yes, this is our fourth question. This one says, a die, I have not a die is a singular of dice. You have one die, two dice, and each die has 6 faces. If you play Ludo, you'd have seen that. If 1, 2, 3, 4, 5, and 6 faces is a cube. Okay, so a die has 4 of its faces colored white. That means 4 of the faces are white, and the remaining 2 colored black. What is the probability that when the die is thrown 2 consecutive times, the top face will be white in both cases? That means we are throwing it twice. So probability that the first time it will be white. Then let's analyze the English. Is it going to be first time white or second time black, or first time white and second time white? What they told me was probability that the top face will be white in both of them together. That's and. So white the first time and white the second time. That's the probability they want from us. Well, what's probability of getting white at all? I have 4 white faces over how many faces in total? 6. And becomes times again 4 white faces over 6. 2 here is 2, 2 here is 3, 2 here is 2, 2 here is 3. 2 times 2, 4, 3 times 3, 9. And that is option C. It is truly this simple. Probability is a very, very simple topic. Okay, let's keep going. This time, working at the year 1998, question number 49. And yes, I believe this is my 5th question. This one says, in a recent zonal championship game involving 10 teams, teams X and Y were given probabilities 2/5, and probability of X was 2/5, and the probability of team Y winning was 1/3. The question asks, what is the probability that either will win the gold? Now remember, probability for either, English language, either or. They're asking what's the probability that either X wins or Y wins, which means definitely I'm looking at probability of X or Y. So all, as you are aware, is plus, so that is 2/5 plus 1/3. Well, LCM, 5 times 3 is 15. 15 to 5 is 3. 3 times 2 is 6. 15 to 3 is 5. 5 times 1, 5. 6 plus 5 is 11/15. Which when I check my options is option C. So you see, this is the answer. Probability is very, very simple. Analyze the English and put that into your solving. Okay, time for our 6th question. 1998, question 50 this time. And for this one, we are told, if X and Y can take values from the set 1, 2, 3, and 4. That means X and Y can only take values from one of these 4 options. Find the probability that the product of X and Y is not greater than 6. Now please note, if you have a probability question, they're asking you to find probability of either products or sum or difference or quotient. The easiest way to do it is to draw out a table and actually get those products. That means I know for X can either be 1, 2, 3, or 4. And at the same time, Y can either be 1, 2, 3, or 4. I'm going to see what the products will be. Well, 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, 1 times 4 is 4. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16. So I want to find the probability that the product is not greater than 6. One product will not be greater than 6. So let's check the different products we are seeing. Not greater than 6, 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 not greater than 6. This is also not greater than 6. They did not say probability that the product is not greater than or equal to 6. 6 is not greater than 6. No, 6 is equal to 6. That means 6 is included. So 3 is not greater than 6, 6 is not greater than 6, and 4 is not greater than 6. So probability of not being greater than 6 becomes, how many of these are less than 6? 4, 7, 9, 10. And how many products do we get altogether? 4, 4, 4, 4 is 16. 2 into 10 is 5, 2 into 16 is 8, which is option A. So you can see probability remains as simple as ever. Just remember, if the question has sum or products, do well to find that sum or products in a tabular form, as that makes it easy to actually count them out, count out all the different things that could happen, instead of trying to think of them and maybe losing track of one or the other. Okay, my next question, this time from 1999, number 42, says a number is selected at random from 0 to 20. Probability that the number is an odd prime. Let's start all the numbers. Let's just get all the numbers from 0 to 20. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and finally 20. Probability that is an odd prime. Odd numbers are those that cannot be divided by 2 without remainder, while prime are those ones that can only be divided by themselves and 1. So 0 is not a prime number, 1 is not a prime number, but 2 is, 3 is, but then they said they wanted odd prime. So while 2 is a prime number, 2 is not odd. So that removes 2 from contention. 4 is not a prime number in the first place. 5 is a prime and it's odd. 7 is a prime and it's odd. 19 is a prime, it's odd. 17 is a prime, it's odd. 13 is a prime, it's odd. And 11 is also an odd prime. So these are my odd primes. As a result, I know therefore that the probability of picking an odd prime becomes, how many odd primes do I have? 1, 2, 3, 4, 5, 6, and 7. And how many numbers were there altogether? Well, 10, 20, 21. So I had 21 options, but only 7 of them fit the criteria. Can I cancel out? Yes. 7 into 7 is 1. 7 to 21 is 3. So my answer is option B. So I hope you are getting this. The solving is truly it's just very, very easy. Just follow the rule and you definitely solve your very, very simple question. Let's see. So we have this one now. I think this is question 8. This one comes to us from the year 2000, question 41. And it says X and Y are 2 events. Probability of X or Y is 0.7. And the probability of X is 0.4. If X and Y are independent, find the probability of Y. This is very, very simple. Why is that? Or is right here. I know that probability of X or Y means probability of X plus probability of Y. What's probability of X or Y? 0.7. Probability of X is 0.4 plus probability of Y. Collect like terms. Probability of Y becomes 0.7 minus 0.4, which is 0.3. Option A. So these are all exceedingly simple, very, very simple. To round up, we're going to take just one more question on that probability, and we shall call it quits with this very easy topic. Let's see. This last one comes to us from the year 1995, and this is question 39. Now, please note there are a lot more recent probability questions. Don't think they've stopped setting it. Just happen to be solving these older ones. So you can check forward. They set probability pretty much every year. This one says, let P be a probability function on a set S, where S equals to A1, A2, A3, and A4. Find probability of A1 if the probability of A2 equals to 1 over 3, probability of A3 equals 1 over 6, and probability of A4 equals 1 over 5. What this means is very, very simple. We have a probability function on this set, which means there are 4 possible things that could happen in this set. There are 4 possible things that could possibly happen in this scenario. But this is not a classical probability. If it was just 1 over 4, this is statistical probability. So as a result, we know that probability of A2 is this, probability of A3 is this, probability of A4 is this. And find the probability of A1 being the event. Well, it's quite simple. Remember we said probability of every possible combination, probability of you happening plus probability of you not happening is always equal to 1, which means that probability of A1 plus probability of A2 plus the probability of A3 plus the probability of A4 must be equal to 1. I do not know the probability of A1, but I know that A2 is 1 over 3, A3 is 1 over 6, A4 is 1 over 5 equals 1. Let's send all of them to the left hand side. The probability of A1 becomes 1 minus 1 over 3 minus 1 over 6 minus 1 over 5. Well, what's my LCM? LCM will be 30. 30 times 1 is 30. 30 into 3 is 10. 30 into 6 is 5. And 30 into 5 is 6. Let's subtract. 30 minus 10 is 20. 20 minus 5 is 15. And 15 minus 6 is 9 over 30. Remember, you never see this in the options. Why? We like to simplify. Lowest form. 3 into 9 is 3. And 3 into 30 is 10. Meaning that my answer is option D. So you see, this is how simple probability is. A very, very easy topic. And with that, we've come to an end of this topic, which means that, as usual, it is time for you to get some questions which you can solve as you prepare. So I'm going to give you just 3 simple questions. The first one is from the year 1998, and it is question 35. The next one is from the year 1997, and it is question 39. While the next one is from the year 1997 and question 38. So try your hand on these 3. Remember, you can comment your answers below this video, and if right, we'll let you know. If wrong, we shall also let you know and give you advice on how best to get your answers. Also, get your O3SCHOOLS JAMB app and activate it. And within the app, you'll find many more questions on probability. Do well to solve as many as possible. Thank you very much for watching. My name is Athanasius.